The amperage used in the voltage drop formula should be the total amperage of the branch circuit, which is the amperage of all fixtures combined. The voltage drop formula calculates the voltage drop between 2 points in the circuit. In this case, you are calculating the voltage drop from the source to the farthest fixture at 420 feet. The current or amperage flowing through the circuit determines the voltage drop. Since all fixtures are connected in parallel, the total current or amperage flowing through the circuit is the sum of the currents flowing through each fixture. Therefore, to calculate the voltage drop accurately, you need to use the total amperage of the circuit. If each fixture draws 1.4 amps, the total amperage of the branch circuit is 1.4 amps times 8, which equals 11.55 amps. Now let's do a voltage drop calculation. Using the formula, voltage drop equals 2 times L times R times I divided by 1000, where L equals the one-way length of run at 420 feet, R equals the alternating current resistance per 1000 feet, and for 277 volts, 14 American wire gauge, or AUG, THHN wire, that is 0.342 ohms from National Electrical Code Table 9, and I equals the total amperage of the branch circuit, which we previously calculated at 11.55 amps, we can determine the voltage drop. So, voltage drop equals 2 times 420 times 0.342 times 11.55, divided by 1000. Voltage drop equals 32.43 volts. The voltage drop at the farthest fixture, 420 feet from the source, is 32.43 volts. This calculation assumes that you are using 14 AWG THHN wire, which is a common choice for 277 volts lighting applications.